Well, hello everyone. Welcome to the webinar. Thank you very much for taking the time out of your day to tune in and listen to myself, Ari Mansfield, Account Executive at Sphere Drones, and we've also got Randall Warnas from FLIR Systems here. So hope your day's going well, and we can add a little insight into thermal imaging to your day today. To start with, I'm just going to run through a bit of an intro on Sphere Drones, what we do and what we're about, and also who I am. And then I'll hand over to our good friend Randall from FLIR, and he will be running through the intro to thermal imaging. He's got some great slides and a great deck for you all today. So we're very much looking forward to that. So Sphere as a company, it's been Australian owned and operated since 1954. So we've got 60 odd years under our belt now, and really we've from our inception, we've sought to help Australian consumers and businesses and enterprise in particular understand new technology and applications. So, you know, it started out with radio and television, and we've progressed right through to today drones, and obviously in particular thermal imaging and drones today. So, you know, we see ourselves as a company that seeks to educate and help out in the market. We're not just about what's in it for us, but about providing end-to-end solutions for our customers. And we've got a team of around 20 in 2 locations, which I'll touch on in a moment. 5 currently with their remote pilot's license, and many more chomping at the bit. We've got industrial designers, software engineers, people with backgrounds in aviation and radio communications, a few commerce degrees in there. So a real mixed bag to make sure that, you know, whatever your needs are, we can cater to them. So yeah, like I mentioned before, I'm Ari. I'm an account executive at Sphere Drones. So any questions you've got, feel free to reach out to me. My phone number and my email address are both there. And if I don't know the answer, hopefully I'll know the person who does and can put you in touch with them. And also Randall, he'll tell you more about himself in a moment. But yeah, a real wealth of knowledge with a great background, and he's the guy to talk to in regards to FLIR. And if you do go ahead with some thermal imaging by drone, absolutely, we can talk to you, both myself and Randall, and help you get it set up and be successful. As far as Sphere goes, like I mentioned before, we've got around 20 staff across Australia, majority at our head office in Sydney, and also a couple over in Perth, and we're looking at expanding to the rest of the capital cities around the place to make sure we can service the entire market. Really, the dream is that no matter where you are in Australia, you can get local service and support for your drone. So that's what we're aiming for, and we're well on the way to achieving that. As far as our capabilities go, it's not just sales. Like I said, we like to offer end-to-end solutions. So servicing, training, rentals, enterprise agreements, we've got it all. We can do consulting. We can help you out with pretty much anything in the aviation space as far as consulting goes, not necessarily just drones. And yeah, we're always keen to hear what's next for our customers and help them on that journey. We also do custom solutions. So we have an R&D facility in New South Wales, down in Alexandria, and we've built a number of solutions. Some of you may have seen our water sampler, which we built in collaboration with Sydney Water. We've got some hyperspectral solutions. We've built some of our own gravity gimbals, and we've also done some work with Surf Lifesaving Australia on water rescue options from Mavics and Phantoms and things like that. So, you know, no project is too hard as long as you're willing to sit down and talk about it and make sure it works for both of us. We're keen to get involved. So don't be afraid. There's no dumb questions at Sphere, and we're always up for a chat about anything in the drone or aviation space. As far as training goes, we do have a partner who offers REPL training. So we can do 5-day face-to-face extensive, which gets you your ARN, your AROC, and your 25 kilo multi-rotor. We can also help you out with fixed wing. We can consult on BV loss and anything else you might want to do and help you out with your REOC there. And then for the products we support, we can also offer type training. So there's a lot of options in terms of what we're capable of delivering. Now, just before we really get into things, just interested in seeing how many REPL holders we have out there. So quick little poll up on the screen, very easy one. It's not a trick question. Just wondering, do you currently hold your remote pilot's license? Is it something perhaps you're working towards? So yeah, just let us know yes or no whether you've currently got your REPL and are currently operating drones, just to give us some idea of who we have in the audience today and how we can best help you out. Okay, excellent. And yeah, you'll see there that around 62% of you with us today are REPL holders. So that's great news. And there's 38% of you who I'm sure we'll be able to help out, get them in the future if need be. So thanks very much, everyone there. So yeah, that's really, I guess, the intro into who FLIR drones are. Now, I'll hand over to Randall just in a moment to talk us through thermal imaging and everything FLIR, and hope it's a really insightful presentation for you all. I'm sure it will be, knowing Randall well. If you have any questions, feel free to stick them in and we'll come to them at the end. Now, finally, just before I hand over to Randall, just another quick poll. Have you previously performed thermal imaging by drone? So again, just to make sure we know our audience and can help them out with information that's relevant and understanding exactly where they're at. We're very interested in how many of you have previously performed thermal imaging by drones. So again, very easy, yes or no, no trick questions. Have you previously performed thermal imaging by drone? And if you have, awesome. Hopefully we can tell you something you didn't know today. If you haven't, this is the perfect introduction and the perfect way to get started in thinking about how you can integrate thermal imaging into your drone program. Okay, excellent. And we can see it's about a 60-40 split there. So plenty of people who haven't yet and are hoping to learn more about it today, I'm sure. And also a number of you who have, and you know, hopefully, like I said, we can teach you something new today. So I will now hand over control to Randall.
Thank you. I don't have it yet. But
he will share his slides with you all, and I'll leave you in his capable hands for the next little while.
All right, let me see. Should be coming up. You guys can see my screen. Ari, you can see my screen?
Yeah, absolutely, Randall.
Perfect. Well, thank you, Ari, for letting me be a part of this, and I apologize for the beautiful folks that have to listen to my obnoxious American accent. But my name is Randall Warnas. I work for FLIR, and really excited to run you through some of the basic kind of concepts around thermal imaging and some of the use cases. So because there's a ton I want to cover, I'm just going to skip through any of like the small talk, and we'll get right to it. So again, Randall Warnas, I run FLIR's sUAS business globally. I spend a lot of time speaking at conferences and basically working with every major drone manufacturer, drone software company, resellers, large end users. And before joining FLIR, I was a part of establishing the foundation of DJI Enterprise. So it was just 3 people at the very beginning, myself and 2 of my colleagues in China, trying to get what you know now as DJI Enterprise off the ground, and I've been in the drone industry for about 6 years. Happy to answer any questions that you have. Make sure you send me an email. Keep the FLIR Drones team in the loop if you can, just so that we can all be on the same page and be learning from each other. But I do welcome any and all questions myself, and obviously in the Q&A session at the end of this presentation. So what we're going to do, we're first going to answer the question how thermal drones work, what causes them to function, and then we'll talk about the work that thermal drones do, and then at the end we'll have time for a Q&A. So just the basic idea of thermal is that there's visible light, which is the energy that bounces off of things that we can perceive with our eyes, and then to the right of this kind of graph is a different wavelength, which is going to be I guess radiated energy that comes off of every object around us. And infrared or thermal imaging are interchangeable, and they're broken up. Those technologies are broken up into 3 different types. There's shortwave, midwave, and longwave infrared. Most of the cameras that you're going to be using in drone operations today, especially outside of military or security operations, are going to be longwave infrared cameras. Those are going to be like the ZenMuse XT, ZenMuse XT2, View Pro, Duo Pro R, etc. what's on the Mavic 2 Enterprise Dual is also a long wave camera, just to be clear on that. So the very basic stuff that revolves around thermal imaging is that, one, you're able to see things in complete darkness. Thermal does not use visible light at all. So you could shine a flashlight in it, it could be completely dark, there could be vibrant colors, it doesn't matter. You are seeing energy that's bouncing off of things, not what you perceive as visible light at all. So that's one huge advantage for thermal. Seeing through obscurance like smoke and fog is going to be important for firefighting and those kind of operations that you would expect some sort of things in the air. And it's also why thermal is being used for autonomous driving vehicles, so that they could see through all sorts of conditions and make sure that autonomous vehicles can drive safe. Able to detect people and animals, I think that's pretty straightforward. And then you're also able to measure temperature. And this is measuring temperature without contact. So if you imagine holding a thermometer in your mouth, or putting a clamp meter on a power line, you're able to measure the temperature with touching something. But this allows you to stand off from that subject or that target and measure the temperature based off of the amount of radiated energy that's coming off of it. And we'll talk more about that. Just a few other things. What you're seeing in any given thermal image is really just what is relative within the scene. So when we're looking at colorized thermal imagery, which we'll look at later, a color does not necessarily represent a temperature. It just represents how it fits in the scale from hottest to coldest within any given image. So if you added something new to the scene that was even hotter, the colors would change and everything would kind of adjust based off of the things that you introduce into the picture. Most thermal imaging cameras that you deal with in the drone space are going to be sensitive up to 0.05 degrees, and that's in Fahrenheit, but it's close enough in Celsius. So they're very, very sensitive. For instance, if there's let's say a cattle or a deer that's laying in a spot in some bushes or something, and it has left, even for like up to an hour or more, you could see that there was something there because the heat signature will be slightly different. Things that you can't do, you can't see through glass, you can't see through walls, you can't see through clothes. Those are like myths of thermal imaging. You're just seeing the energy or heat energy that's coming off of the surface. And for thermal, it's different than visible light cameras. 640 by 512 is going to be considered high resolution. So you're not dealing with, you know, a 20 megapixel or even a 10 megapixel camera. You're dealing with very small numbers of pixels in a standard thermal image, and we'll talk more about resolution shortly. So one thing you should think about energy is that there's three ways that we perceive, that these cameras perceive energy. They perceive energy that's being created by the subject. So like for wildlife or humans, we're creating our own energy and our skin is hot. So it can see things because the energy is emitting from the body. It can also see things that absorb energy. That would be like a roof, for instance. So the sun is beating down on a roof all day. It's absorbing that energy in the shingles, and then it releases that energy. The shingles itself is not producing the energy, but it's just absorbing it. And then you could also look at reflected energy. That's going to be like on aluminum roofs or shiny materials, in the same way that we have visible light where you can look at something and see yourself in its reflection, is the same thing with energy, where it will just bounce off and you'll only see the energy that is basically, or you'll only see the temperature of something that is facing that shiny material. And we'll talk more about that concept shortly. So emissivity is somewhat an uncommon word in daily vernacular. So emissivity can be thought of as the opposite of reflectivity. So when you're looking at any surface, the amount or the percentage of emissivity that surface is going to be how true the actual temperature that is coming off of that subject is. So if you're looking at the chart on the right, these are just some estimations, or it's a emissivity chart. And this is as compared as a percentage to a perfectly emissive black body. That means that if you held a thermometer to that black body, it would be the exact same temperature as if you used the thermal imaging camera that was calibrated, because it truly tells you exactly what its temperature is based off of the amount of radiation coming off of it. The opposite would be something like steel or aluminum, which is basically reflecting whatever is behind it. So if, and we're going to talk about this in a second, so I don't want to dive too deep into it, but you basically need to adjust for emissivity in your camera to get a good temperature reading. And there's ways to measure the actual emissivity of any subject. Not every brick is the same, not every piece of wood is the same. So if you are trying to get the exact temperature of a surface, you do need to measure the emissivity of that exact surface. But there are tricks to doing that, and I'm not going to cover them here, but there is ways to make this all happen. So let's talk about reflective temperature. If I have a thermal imaging camera and I'm looking at a person, and a person's normal temperature is 37 degrees Celsius or 98.6 degrees Fahrenheit, if you added something that is very hot in front of that person's face, the person's face would appear to be hotter than it actually is, because it's now receiving radiated energy from something else. So when you're using a drone to measure the temperature of something, you have to consider all of the elements behind the camera that are impacting your subject. So if there is, if it's a cold day, or if the sun is out, or if there are a ton of people in a room and you're trying to measure the temperature of the wall, the temperature will be different based off of the reflected energy that is coming off of everything else in the room. So consider this as another parameter or another variable you need to input into the thermal imaging camera to tell it, to allow it to adjust for those, I guess, those components or those variables that will impact the ability to read a true temperature. So when you look at a thermal imaging camera, the ZEMUS XT2, you pull up the menu, it's going to ask you for the emissivity of the subject you're looking at. It's going to ask for what is the ambient or reflected temperature. Sometimes it's called T-reflect. And you put that in as a temperature of what is everything else in the room or in the area that is impacting my ability to measure that subject. You also need to input the temperature that you're the outside temperature at the time of measurement, and an estimation of humidity. This is just like invisible light or with your eyes. If you're in a very either humid or a polluted environment, it's harder to see. The image is less clear. So thermal imaging cameras can adjust for the impact of humidity and other things that are in the atmosphere and give you a more accurate reading based off of that. So you do need to put those inputs into the camera to get accuracy. And also distance is a big deal. We'll talk a bit about this in a second, but you do want to get roughly 10 by 10 pixels on your subject in order to get a good temperature reading. So that's what this chart is showing. Basically on the left-hand side, you're looking at how close it is to the actual temperature, meaning how accurate your thermal reading is. It does not get to 100% really ever. You would have to be in perfect conditions, but the more pixels that you have on your subject, the better you're going to be able to determine the temperature of that subject. This isn't necessarily for identification or the ability to see the subject. This is for temperature measurement specifically. For the ability to see the subject, you want at least around 5 by 5 pixels, so 25 total pixels on your subject of the camera to see a person or see the defect that you're looking for. So let's talk about resolution a little bit. I mentioned earlier 640 by 512 is considered a high resolution optic in the thermal world. So that's going to be 640 pixels on the horizontal plane and 512 pixels on the vertical plane. That leaves you with 327,000 pixels within your total image. So if you need 10 by 10 to get a good temperature reading at the very minimum, that's going to be 50 of those 327,000 pixels. Or if you need to just see something, you need to get 5 by 5 pixels or 25 pixels of that entire available pixel count. So this is a table I did comparing two cameras. This was comparing the FLIR Duo, which is no longer with us. It has been retired, which is a 160 by 120 camera and a 640 by 512 ZEMUS XT. I did this with a ZEMUS XT1. But what you're looking at is that if you look at the table on the left, this is the altitude in feet. And in the US, and I think most places, 400 feet or roughly 100 meters is the cap where you can fly commercially without having special permissions. So that's why I did it between, I did it every 25 feet up to 400 feet. And what the number that's next to it represents is how many inches each pixel within the image represents. So if you are at least trying to get, say, 5 by 5 pixels on your subject, you can say, okay, if I'm flying at 50 feet and I need to get 5 by 5 pixels, that means that my subject can be up to, for the 640 by 512, you do 1.1 multiplied by 5 is 5.5 inches. That would be the smallest subject you could detect at that altitude. So if you do this in reverse and say, I have a subject that's it's a cow, and it probably is around 7 feet in length, you could put this back into this model and figure out what is the maximum altitude you could fly to find that cow, that missing cow or missing person. So this is why this table is useful. I suggest that you screenshot it. I suggest that you consider it, because if you're using thermal, you're going to ask, how high do I have to fly, or how high can I fly in order to see my subject? This table will answer that question for the 640 by 512 cameras, which are the most common, and 160 by 120 cameras like you'll have in the Mavic 2 Enterprise Dual. You will see that it's much more difficult to locate a person with a Mavic 2 Enterprise Dual, the 160 by 120, at any altitude. Yeah, we could walk through this all day, but just keep in mind this is an important slide. So this shows you a comparison of a 160 by 120 and a 640 by 512 camera at the same altitude. Because you're getting more pixel count, you're getting more clarity. So you could see the cracks in the cement on the picture on the right. You could see the pizza pan, which is an 18-inch pizza pan that is the subject in the middle. So if you were looking for a person, which is roughly this size, at 100 feet or roughly 30 meters or so, it would be very difficult to detect a person with a 160 by 120 camera. Much easier, much clearer with a 640 by 512. These questions of resolution have baffled new users for a long time, and I'm trying to just find ways to make it very concrete and very clear of what you're giving and what you're losing by dropping in a resolution on a thermal camera. So field of view is, whoa, my image is gone. There we go. Field of view is another thing. So this is going to be when you select a lens. There's generally 3 or 4 options on lenses on a lot of the thermal imaging cameras we make: 9mm, 13mm, 19mm, and on the off chance a 6.8mm or a 25mm are the most common. But this is what you're doing. So basically you are widening the field of view, or the amount that you can see at any given time, but you're getting less pixels on the subject that you're looking at. So you're able to fly a lot higher if you are using a 19mm camera, for instance, because there's going to be more pixels consolidated in a smaller area of space. So if you are doing a utility inspection and you have to stand off from the power lines 10 meters or so, you're going to be better off with a narrower field of view to get more pixels on your subject from a farther distance, if that makes sense. So this is what you're dealing with when you're choosing a lens size. I am of the belief that it doesn't matter. If you get a 19mm camera, you're probably going to be happy you got one. If you get a 9mm camera, you're probably going to be happy that you got one. There are some instances where you really do need a certain configuration, but I just suggest that people don't get hung up on that. 19mm is always safe because you could always fly higher, and if you need a wider field of view, but you have that ability to get a lot of pixels on your subject if that's what you require or what the use case requires. Frame rate is something hard to explain, and because we're doing this over a webinar, it might be hard for you to see in this video what frame rate does, but I'm going to play it anyway. So on the left-hand side, we have a 30 hertz camera, and on the right-hand side, we have a 9 hertz. Now, because of the webinar, it might be choppy regardless, but on the left-hand side, it's a very smooth, fluid motion where there's 30 images per second that are being shown to our eyes. For the 9 hertz video, it's 9 images per second, or 1/3 of what's being shown on the 30 hertz, so it looks more choppy. This is done, we make both 30 hertz and 9 hertz for export control reasons. The 30 hertz cameras are not restricted in Australia or New Zealand, so there's no issue in getting you 30 hertz cameras there. But because these things can be used also, thermal cameras are used also for like heat-seeking missiles and other sort of weapon systems. That's why there's this control, because the 9 hertz or the 7.5 hertz in this case is not capable of doing those sorts of missions, I guess, for thermal. So hopefully that makes sense. It's really hard to explain without imagery, but the imagery is not great over webinar. We will move on. All right, so the last question is a question of whether you are doing a qualitative mission or a quantitative mission. Now, there are cameras like the Zenmuse XT-R or the Duo Pro R or the View Pro R. The R at the end of it means radiometric. Now, the XT2, all the cameras are radiometric. The Enterprise Dual is not radiometric. Most of the cameras that are integrated into other drone platforms are usually non-radiometric. What that means is that the qualitative side it means a non-radiometric camera. You are going to see relative temperature differences within the scene, and that is what your mission should be focused on. You don't necessarily need to know how hot the person is that you're looking for that's missing in the forest. You don't care if they're 37 degrees Celsius or 32 degrees Celsius. You just want to find that there's a living thing. So because that relative temperature difference is enough, you don't necessarily need a radiometric camera. The targets just are different than the surroundings, as I show here. Now, these are going to be the most common use cases for drone technology today, for thermal drone technology, I should say, like firefighting, law enforcement that are finding people, search and rescue, roof inspection, anything where you're just looking for a difference, an anomaly. You don't care how hot it is, you just care that it's not the same temperature as something else. Now, the opposite is going to be quantitative, or these are going to be the radiometric cameras. They are measuring the absolute temperature of that subject. When that matters in your mission, when a component, and I'm going to use Fahrenheit because it makes more sense to me, I apologize, but if a component on a power pole is 150 degrees Fahrenheit, that could be normal. But if I measure it and it says it's 185 degrees Fahrenheit, I know there's a problem. So if I need to know the actual temperature of that component to know whether I should send up a technician or not, I need to use a radiometric camera to take that temperature data to be able to put in all the inputs like emissivity, background temperature, humidity, and all the atmospherics, and get a temperature reading that I can trust. You can see on the right-hand side, the image all the way to the right, where there's that one breaker that's lighting up. This obviously wasn't done by a drone, but the concept is true, that breaker is clearly different than all the other breakers, but is it different by 1 degree or is it different by a whole bunch of degrees? Now, if you look at the scale on the right-hand side, I believe this is in Celsius, that breaker is 42 degrees Celsius, which shows that to a technician, an electrical technician, that's a real problem and that needs to be taken very seriously. Where if it was just slightly over, using a non-radiometric camera, you wouldn't be as concerned. Hopefully all of that is clear. Questions, make sure they flood in if I'm not being clear so I can take another stab. So another piece of technology is MSX. This should play through and show you the difference between an image with MSX and an image without MSX. What this is only when you have a thermal and a visible camera or RGB camera that are bore-sighted and connected within the same system that we can enable this capability. What it does is it embosses the RGB image on top of the thermal image to give you more context. So here we have a tank of flammable material, but we wouldn't know it's flammable just looking at the thermal image until we see that it's propane, that it's flammable. There's the placard on the right-hand side that gives us exactly the ability to act accordingly with all the information in one image. If in the old days you were flying a Zenmuse XT with just thermal, you would see the image before the overlay. You wouldn't know what that is. So if there's a rollover of a train and there's a bunch of these tanks, you don't know what the gas is that's spilling out of it. You could make guesses, but if you have this kind of MSX technology, you could just fly one mission, one time, and get all this data in one. I think it's really important for other things like search and rescue, or for law enforcement if you're trying to find a address on a house or read a license plate, see the texture or the pattern on someone's clothing. Those are all things that would be done with MSX, where thermal alone would not show you any sort of any of those things. So I'm going to start jumping into some use cases. Here I want to talk a little bit about law enforcement. I think that this is one of the more important use cases for thermal imaging, not only to protect communities, but also to find missing people. Now, in this particular video, they're using a feature called isotherms. What isotherms does is allows you to set a temperature parameter of everything that you want to be highlighted within the scene. So knowing that people are roughly 37 degrees Celsius, you can say everything that falls between 35 and 40 degrees Celsius, I want to be highlighted yellow, and then you'll get imagery like this. So this was done in Texas. They had a officer, this was in a training, but an officer go hide somewhere. He was about a half-mile away from the facility. The drone found him within minutes. The dog found him after the drone, clearly. But one of the cooler ways to see how this technology makes finding people very easy. This video could have been done in the middle of the day. It could have been done in the darkest of night with not a single light in the area, and you would still see this exact imagery. And just seeing how potent it is to find people is quite impressive. Now in the US, I have some stats on the left-hand side, but I venture there's about 1,100 or 1,100 law enforcement agencies using drone technology today in the US. There's 18,000 law enforcement agencies in the country. So we're about 10%, not even. And I still think that the proliferation of this technology is going to rise so rapidly because those initial early adopters are finding so much good use of the technology. So getting in on it now, learning on it now, is just going to benefit everyone going forward, and that includes, you know, FLIR is around to serve these kind of communities and serve this use case. Finding people, like I said, very easy. Mission on the left-hand side, a teenager was lost in the mountains in Norway. They were able to find him with a drone quite easily. On the right-hand side, it was a toddler about 2 years old that wandered away from a campsite. They flew a thermal imaging drone from that campsite along a path, and they found him maybe a mile or so away. So isotherms may help in finding people, but you just want to be very careful and practice a lot so you know exactly what to expect, because sometimes the ground is roughly the same temperature as the person, and you need to know how to adjust for that, or when to say, yeah, the drone is not really going to do the job today. So just keep those things in mind. So firefighting is another huge application for using thermal imaging drones. Being able to locate hotspots even when there's a bunch of billowing smoke is very important, and you can send this imagery back to a command and control center so that somebody could be making determinations on, you know, do we have enough people there? Should we send specialized equipment? And make sure that everyone is operating in a safe manner to make sure that everyone can get home. I think that also, when you have drone technology, it doesn't take a cameraman getting up in the grill of everyone and kind of getting in the way or putting themselves in danger to get this kind of imagery. So training videos are going to be much more useful for fire departments going forward, because they're of actual scenes showing actually how they thought about putting out the fire and the methods that they used. I have a few of these firefighting things I'll run through really quickly. This hot spot under the tree on the right-hand side is a fire that was pushing up through the rafters of the ceiling or of the attic, and so you wouldn't see with the naked eye that there was any problem there. But you know, if someone walked on that, they could fall right through. Also, they're able to go straight to these hot spots and put them out before they become bigger problems. So what's happening here is there's two firefighters that are cutting a ventilation hole in the roof. This allows the toxic gases to escape through the roof, making it easier to fight the fire from inside. So department can look at this and see, you know, if these guys did the ventilation cutting appropriately, if they are safe. They can see the status of how things are going, and again, you're able to locate hotspots. I'm going to skip through this before that's done, just in the consideration of time, but here's another use case where you can see these hot pockets that are, if I can get this play, oh, it says cannot play media. Well, there are hot pockets here that are stuck in a wall. This is after this structure had burned down. You can fly a drone over the top of it to make sure that all the fire or possible places where it could reignite are put out. So the firefighters will come in and see these hot spots, break out the wall and spray it so that it doesn't have the ability to yeah, like I said, reignite the fire, makes it safer for the insurance adjusters, the homeowners, and the firefighters themselves to go through and do their investigations and do their work without worrying about possibly being injured. So that's another great use case for drones. Solar inspection is becoming extremely popular use case for thermal imaging drones because it is so much more potent than the traditional methods of doing solar inspection. Rather than having a car or a person on a little Segway riding up and down these aisles, these rows of panels, they can use a drone and basically fly over the entire field in a matter of maybe a day and process all that imagery rather than a few weeks to cover a whole larger solar field. And the ability to see anomalies like you see on the clear why it's useful. Traditional solar inspections are done about once every 6 months. Using drone technology, especially if you get to the point where full autonomy is possible, you'd be able to do these much more frequently, making sure that the strings, damaged strings, are replaced more frequently or more readily, and keeping the energy output of the solar fields at a maximum. So this is where there's a ton of ROI being done and a ton of investment being done by smart software companies to do orthomosaics, to be able to stitch all this imagery together, make it one big map so that it makes it very easy for the technicians and people that manage the assets to keep up with the repairs. So roof inspection is another great qualitative way of using thermal imaging. So here we're just going to be, it scans through a bunch of different color palettes, but it doesn't take a genius to see that there's a problem. These problems are water that has gotten underneath a rubber membrane on top of a roof. So with the naked eye, you could see that there was some wear and tear, but you can see specifically where water is settling. And this is a roof that needed to be replaced almost entirely on the left-hand side because it was just so rotten. And if a person were to walk on it, there's a chance to fall through it. There's a chance to, cause greater damage, and it's just a much safer and much more efficient way to do these scans from the air than do them from the ground. Another use case would be for ranching. So if there's large areas of land where cattle or other animals kind of roam around, you're able to see animals quite easily, very quickly, to determine whether one is strayed off. You could also do count estimates. There are software companies that are doing the counting for you. I can't vouch for how accurate, but I think over time, the ability to do wildlife or stock counting from an image like this will be quite easy in real time. So you can know whether you are, if you're a rancher, if you're producing more, if you have animals that are missing, all of those things. And this was done at quite a long range, and you can see how easy it is to determine where the wildlife is. Here's another video that I think it's playing sound, or at least it is for me. So if that's it's kind of annoying, but this is a bunch of wild hogs that were eating about $10,000 worth of peanuts a day. This is on a peanut farm, so the farmer wanted to know where they were coming in. So he actually hired out a drone company to come and look where the hogs were coming into his farm. So once he found the entrance of where their paths led to, was able to go and take care of, mending a fence and also maybe doing some hunting. I'm not sure, but this was done in pitch dark, so you wouldn't be able to see anything at this time of day, but they were able to fly above and kind of get an idea of what was ruining their crops. This is another pretty cool video of San Diego Zoo in conjunction with a few universities. They were in Costa Rica, I believe, and just looking for wildlife in canopies of trees. So here we have howler monkeys, and you can imagine, it's the same kind of makeup as a person. So using isotherm, you're flying above trees, which are very dense. And at the start of this video, I'm going to drop back to it. This is what it looked like with a daylight camera. You can't tell me that you would see anything, a monkey, a bird, a snake, anything in that kind of foliage. But using a thermal imaging camera, they were able to detect where there were these families of howler monkeys and go study them. So they weren't studying them with the drone camera. They were just flying over the canopies until they found what they were looking for. But really compelling video that just shows how powerful thermal can be in it as an advantage over using just an RGB camera. So one of the coolest things that I've done in my drone career is working with an organization called Ocean Alliance. I think that you Aussies maybe know of the Sea Shepherd, which is anti-whaling, whale poaching vessel that I think was based in Australia for a long time, but they made like a TV show about it, often looking for Japanese whaling ships in the Antarctic. But Ocean Alliance is kind of the scientific side of Sea Shepherd. They're linked and they do a lot of good work for saving whales. So I got on one of the vessels that was based in Massachusetts with Ian Kerr, Dr. Ian Kerr, who's in the middle, and Ian Smith, who's on the left-hand side, who is the host of the Commercial Drone FM podcast. And we went out to do something for the very first time. What we were doing is we were flying above humpback whales, and we were getting the first radiometric temperature reading of a whale's blowhole. So if you imagine that these whales spit up, I don't even know what the PSI is, but extremely powerful plumes of snot. And before doing this thermal work, Dr. Ian Kerr started what was called SnotBot, which is flying drones with petri dishes into those plumes of snot, collecting samples and being able to study them in a lab, which was very difficult or maybe impossible for them to do in the past. With drone technology, it made it possible. Now we were getting the first temperature reading of a whale. So if you look at a human being, you know, if I'm sick or feel sick, the way that a doctor or my wife is going to confirm whether I'm sick is she's going to take my temperature. Well, whales, for all that we've done to study them, we never knew their temperature of a living, breathing, functioning whale. There was just no way to get it. So now using a thermal imaging camera, we got that. This is an image of that has been, I guess, tuned in one of FLIR's softwares so that we could study the actual temperature of that blowhole. A couple thousand samples of multiple hundreds of specimen from in Africa to the Gulf of Mexico to the the Arctic, not the Arctic, the Atlantic, of different whales, and they're putting all that data together to say, what does this tell us? Now they believe that through the temperature you're able to determine the gender of the whale, you're able to determine if the whale is pregnant, and also if the whale has any significant illnesses. Now there could be much more that is to be done, but yeah, this is something that we're actively working on, and what is one of the most exciting things to basically break ground in something in the scientific world. Now, if you look just real quick on these object parameters, you can see that the emissivity was put in at 0.85, so that means 85% of a true black body would be the surface of a whale's blowhole. The way that was determined is one of my colleagues did the emissivity of the inside of his mouth and figured that it'd be very similar to a whale's blowhole. Then it also, you put in the distance, you put in reflected temperature, atmospheric temperature, humidity, all these things come into play right here to be able to tune this image to get you, a positive or at least a confident temperature reading of what that whale's blowhole would be if you could get an actual thermometer in there. Another use case is anti-poaching. This was a imagery from, I keep mixing them up, but I think this might have been Costa Rica or Panama, where they were looking for poachers of jaguars in the forest. So again, looking at the RGB image, you wouldn't see much. Kind of at the top, you can see some smoke, but the image on the left is the thermal image of their campfires. So then you're able to geo-reference that image, send it to law enforcement or send it to an agency that can do something about it, and they can go and stop poachers from their illegal activity. This was not done on a drone. This was done on a Cessna manned aircraft, but it was a View Pro that's on that end with a GoPro above it. But just another creative use case in order to serve society and do something positive with the technology. With that said, it is time for your questions. I hope that that wasn't too fast. I know that it was probably a ton of information and maybe bored you to death. I don't blame you. At one point in my life, I said, I am so glad that I don't have to do this boring stuff every day. And now I do something that I consider extremely exciting, but I would understand if you like me at some point or one point thought it isn't that interesting, but I do my best. So please, with follow-up questions, shoot me an email, randall.warnas@flir.com. But if you have questions in the GoToWebinar toolbar, then we can go through those right now, real time. Does that sound good, Ari?
That sounds great to me, Randall. Thanks very much for running through that. A real crash course in thermal imaging, and I'm sure a lot of value for people in there. We do have a few questions over in the sidebar, and I'm sure people will pop more in as we run through them.
Okay.
A couple of people have asked if it's worth having like a portable weather station or something that allows you to see what the weather is to help with the setting changes on your camera. What's your opinion on that one?
Absolutely. So those aren't that expensive. And if you take a real thermography course, they will tell you that that is like one of the most necessary tools to do temperature reading. Now, if you are just looking for a person, you don't necessarily need to do all those inputs. It's a nice to have, but really this is just to make the most accurate temperature reading possible.
Yeah, excellent, excellent. What else have we got here? Do you get better results if background light is lower? So does, a sunny day versus imaging at nighttime affect the results at all?
Yeah, so absolutely affects the results, but remember it has nothing to do with the light, right? Because we're not talking about visible light at all. What we're talking about is things like solar load. So if you have the sun beating down on the grass, for instance, all day long, when the sun goes down, that grass is still going to be giving off energy. So you're going to have what's called temperature load. Now, water holds that temperature load longer than anything else, really. So if you're going to be inspecting a roof, at the end of the day, the water is going to appear warmer than anywhere else on that roof. So you're going to be able to see that anomaly because the roof is going to cool off faster where there isn't precipitation. The opposite will be true in the morning, where the water will be cooler than the rest of the roof, because that's just, I guess, the nature of water. So it's kind of when you talk about what time of day, it depends on the mission. Most missions are going to be best done when the sun is barely going down or when the first thing in the morning. There are other missions like solar inspection when you want to do that while the sun is at its highest, I guess, because you want the panels to be working when you're doing those inspections, and they're working when the sun is being absorbed by the panels, if that makes sense.
Yeah, absolutely, absolutely. That's great. Also got a couple of people here with some questions around specific drones. So what drones are capable of integrating with the FLIR cameras?
So I guess it depends on size, weight, and I guess payload capacity. We have drone agnostic cameras like the FLIR View Pro, which has been around for 4 years or so, and it's tried and true, tested on so many things. But if you have a Phantom 2, Phantom 3, Phantom 4 that you want to get thermal imaging capabilities on, you can buy a FLIR View Pro and integrate it onto those airframes, because it's not going to feed through the DJI Go app or anything like that. If you're not a fan of DJI and you want to put a thermal imaging camera on an Autel, Unique, Intel, any other drone manufacturer drone, then you can use the FLIR View Pro as well. It's drone agnostic. It's just being carried by the airframe. It's not talking through it generally, unless you do some work on that side. But all the plug and play stuff we do is with DJI. We have an exclusivity agreement with them. So the Zenmuse XT, XT2, Mavic 2 Enterprise Dual, all of those integrated systems are done with those DJI airframes.
Okay, excellent. And we've probably got time for 2 or 3 more questions. So if you've got something which you're really wanting to know, pop it in the question box in the sidebar, or otherwise feel free to take down my or Randall's email and reach out to us afterwards. Chris is wanting to know if you could touch a bit on weed or vegetation identification using thermal imaging.
So yes, there will be a different temperature for vegetation as rather than if there's no vegetation. But those missions are generally best done with an RGB camera. I think that software companies like Pixfordy and Drone Deploy have done really great work in detection of vegetation, especially when it's up and down railroads or near solar panels or near power lines. And so that technology has already been worked out really well with RGB that you wouldn't necessarily want to use thermal for that.
Yeah, fair enough, absolutely. And I guess that's an important point to make, that, you know, thermal can do a lot, and it's a great tool, but it by no means replaces, you know, RGB cameras and LiDAR and some of those other solutions. It's best to,
Correct.
you know, use it all together and use the best payload for the job.
Yeah, I mean,
Um,
what I say is that thermal is the most promising payload for industrial applications aside from the RGB camera. The RGB camera can truly do so much lifting in a multitude of use cases, but you can't do power line inspection with an RGB camera. You can't do solar inspection with an RGB camera except for looking for bird poop or cracked panels, and you can't do, you know, you can't do night search and rescue or anything like that with RGB cameras. So there's still a function, but thermal has its place in the world, as does LiDAR and near-infrared multispectral cameras.
yeah, excellent, excellent. We'll just take 2 more questions, but do feel free, if you do have anything to ask, to pop it in that sidebar, and we'll get back to you in the coming days via email. One interesting one here, Randall, is there FLIR specific training or certification and varying levels of that?
That is a very good question, and I appreciate it, because one of my big things is I like to educate and just kind of advocate for the technology, but never want to feel like I'm trying to push anything on you. I'm not trying to sell you anything. So if you leave this and feel like you know something you didn't know before, my job is done. But FLIR does own an organization called the Infrared Training Center. This is a level 1 to level 3 certification entity. They do courses that I believe most of them are 4-day courses, and we do have courses that are specific to drones. I don't know how many of the drone ones have made it over either the Atlantic or the Pacific, but yeah, we do have courses through ITC that is yeah, that do certify you as a thermographer, and that will be a differentiator and an ability. You will have the ability to sell yourself as a drone service provider, for instance, as someone that has the certification to do this kind of work. There are aerial thermographers in the U.S. that make hundreds of thousands of dollars. I know one that is very, very successful, and then some that are, you know, in the relatively successful, making, you know, 100 grand flying drones and flying thermal drones. The payloads are a little more expensive. The technology is a little more sophisticated, but you can make a decent living when you really know what you're doing and can go serve the largest customers in that space, the oil and gas people, the power line people. You know, there's money to be made, and then there's also societies and what am I, communities to protect, and that for the public safety, they're the #1 adopters of the technology right now.
Yeah, excellent. And final, I guess, live question we'll take. And again, I stress we'll get back to everyone who's popped a question in that sidebar via email. But the final live question we'll take is from Gary. Gary's a good friend of us here at Sphere, and he's wanting to know,
Hey, Gary.
when flying solar panels, is there a recommended height and angle to conduct the inspection?
There is, and it's another great question. I don't know if I can share links in here, but we just put out a 4-part video series with an organization called Raptor Maps. They are a kind of a software processing company for solar panels in the US. Bunch of MIT trained guys that are really smart. And so that 4-part video series is available online. It's free. If you type in like FLIR solar drone videos, you'll find it. There's also a download that gives you a bunch of best practices that's really, really good. But if we're talking about standards, I think usually around 50 feet, so I guess 20 meters above the ground with a 19mm lens, radiometric in this case for solar inspections. And so that's the recommended height. I don't remember the other question, but if you're doing any mapping, you want to have about 80% overlap and 80% side lap to process those orthomosaics. Did I answer that whole question?
Yeah, absolutely. And we can probably get some more info to Gary, and
Yeah.
I'll get that link off you afterwards, Randall, and make sure we provide that to all of the attendees today.
Sounds good.
A few people as well wondering, will this webinar be available afterwards? Absolutely, we'll be sharing a recording and we'll try to share those slides with you as well. In particular, I know a number of people are interested in seeing that frame rate video from Randall, because it was a little hard to spot the difference in the webinar, but it'd be great to see that one afterwards as well. So thank you very much to everyone who tuned in, everyone who's asked questions, everyone who's taken the time to listen to myself and Randall today. Feel free to reach out at any time. My details are up on the screen. And thank you in particular, Randall, for taking the time out of his day all the way from Utah to join us and to share some of that information with us. Really appreciate it, Randall.
Really my pleasure. And I just sent in the chat to you the link for that solar inspection video series, so you can share that with the people that attended.
Yeah, excellent. I've just put that in the chat for everyone. So I'll leave the webinar live for a minute or two so you can grab that chat. There's also a Sphere Drones capability statement in the handout, and a last, I guess, opportunity to get any questions in the sidebar that we will reach out to and everyone and answer. So thanks very much, everyone, for your time, and hope you enjoy the rest of your day.
Appreciate it. All right. Talk to you guys soon.